Okay,
Yes.
thank you very much. Okay, my name is Ulrich G. My presentation will be outlined in 5 points. First one, background, summary, and for me, the key important part of my solution, which is similarity adjustments and the way I predict during reference time, and maybe some conclusions about my important findings. So I am Ulrich G, a senior data scientist at the Crédit Agricole, which is a bank in Paris. So I live in France, in Paris. But before sliding into a data science career, I was an economist. I namely worked for international institutions like IMF, the Central Bank, and even the UNDP. For my background, I had 3 different master degrees in mathematics, economics, and machine learning. And in the past, I also took part to mathematical Olympiads, and I won medals there back in 2009, 2010, and 2011. And since 2022, I'm a part coach of the Ivory national Olympic team. So basically, some knowledge about high school mathematics helped me in this competition. Um, Concerning my solution, it is a very simple one. Honestly, I did build on what people have been doing on Kaggle for this competition. So since the beginning, I decided only to focus on the efficiency track because I sensed that I wouldn't have enough time to really go through the competition. So I just take 3 weeks to frame out my solution, and at the end of the day, it paid off. So I just use at a time which was the best public model because since I was only focusing on the efficiency track, I was only interested by very relatively small LMs, not big one like Quen and Mistral, but going with the very light ones. So there was a public model from Busha Mohammed that I used. So my approach was very classical one. So I create a prompt for any question and wrong answer, and then I embed this prompt and all of the misconceptions and find the most similar ones. But the only difference is that I do adjust the similarities by what I call pointers to take into account mathematical notions. I think that Raja called them mathematical concepts. It is quite the same. So to go in it in detail, so as you know, the questions encompass many mathematical concepts. Like I think there were questions about gradients, equations, triangles, angles, statistics, pie charts, diagrams, and everything. So to me, after investigating some outputs of the similarity matrices, I noticed that there was what I call blatant errors. Because sometimes when you have questions related to gradients, you can have some misconceptions that goes with simultaneous equations or even triangles. So to me, the key part was to adjust the similarities that I computed from the models to kind of give an advantage to the misconceptions relating to the same concept as of the original question. So what do I do? So the pointers that I do is designed so that, as I said, if a question, so that the question and and the misconceptions of the same concept get some bonus. For instance, if you have a questions about unit conversions, I am supposed to give some extra point to the misconceptions pertaining to units conversion, like liter, centimeter, and things like that. That's what I do. So basically, the pointers that I namely built on the on a couple. So my couple that I considered was the construct name, because in the data set that was given to on Kaggle, the let's say the more detailed information about the question was in the field called construct name. So I use all of the construct names that we had in the training data set, and I try to map them with all of the misconception that we had according to the fact that they belong to the same mathematical concepts. And after that, there was something that I need to address, is that what I call the new construct names, because actually in the private data set, there was some construct names that we didn't find in a training data set. So I decided for this to advantage the misconceptions that was not seen in the training data sets, so that the bonus points are only given in this case to the misconceptions not used in the training data set. Now for the pointers that I built, I had two categories. What I called the the safe association and a high association. For example, if we have, let's say, a question pertaining to angle, uh, so what I call a safe association will be all of the misconceptions that are clearly speaking about angles or angles computations. But at times we can have some what I call potential association, because a student can have some errors in the computations, but like maybe you can have an error by simplifying a fraction. So even though fraction is not the same mathematical concept as angles, but we can have in this competition or in this with this data set some potential link between these two mathematical concepts. That's how I frame out the pointers. Um, how do I project? So basically, I use a simple. It's not a prompt per se, but I call it prompts. So to represent the couple of the question and the wrong answer, I took the subject name, the construct name, the question, and the wrong answer. And when I have this, I retrieve the embedding from the public model as I said. And what I do is that I use two bonus. So alpha will be the bonus point for the safe association, and beta will be for what I call the potential association. So that once I have computed the similarity from the prompts embedding and the misconception embedding, I just had alpha for the safe association and beta for the other ones, and nothing if there is no pointer or no association. So during the competitions, I play a lot with the values of alpha and beta, and based on the public leaderboard, the best parameters that I had was alpha and beta equal to 0.15, and that's how I used to predict for the competitions. So my it's not really something that is quite novel, but to me the key point was to give a kind of mathematical knowledge context to, I mean, to what I call the prompts that takes into account some mathematical concepts. And when you put it into the similarity matrix, at the end, you were able to have good results. So the public model I use scored around 0.22, but with this matrix adjustment, I can score around 0.28. And that's how I ended up third in this efficiency track. So that's all, and I will answer to your potential questions. Thank you for your attention.
Thank you so much. This was a very, very, very helpful presentation. And I have a couple of questions just from as a curious learner. So if I'm understanding correctly, you noticed a
Yes.
limitation to the similarity scores. In a sense, they had surface level similarity. They don't account for like the
Yeah.
nuances of these mathematical notions. And that's why you had these similarity matrices and adjustments. I'm
Yeah.
curious then, for the values of alpha and beta, you said you landed on them essentially both being 0.15, and I'm curious what you noticed when alpha was significantly higher or just slightly higher. That yeah.
Yeah, properly. I sorry, I forgot to say something, but it is not on the slides. Basically, to do things in the proper way, we need to cross-validate the values of alpha and beta, but I didn't have time to do it. But usually, when we are dealing with regularization in regressions, usually we use 0.1 as one of the starting value, and then things can be adjusted by optimization. That's why I took values around this. But in the private leaderboard, I think the best values was alpha equal beta equals 0.5. So I didn't choose even the right, I mean, the optimal values of alpha beta, because I didn't validate them properly. And there is also a big limitation to what I use to the pointers that I did, is that these pointers are static, so they are not dynamic. So as I said, there was a risk in for what I call the new construct name, because it's like I was making an hypothesis that probably the misconception will be one I didn't see, so that it gives advantages to the new misconceptions, but it is not necessarily the case. So that's one of the main drawback of these pointers. So what I wanted to do to improve it, but I did not have time to do it, was to take part of these pointers that I've constructed and to train very specific embeddings, so that with this model I can associate the new construct names to the most relevant misconceptions and then choose it automatically, but not in a very fixed way. I don't know if I've answered the question. I've been very long, but
Oh,
yeah,
no,
that's what I can say.
this is helpful. And I guess I'm also just also assuming there that I think maybe the time constraint maybe kind of prevented that sort of exploration of these additional approaches. Is that also?
No, it was not the time prevention. It was that at times I was busy, because as I think it was Deepam, because Deepam he talked about the trade-off between time and scoring. So in this sense, there was I had a lot of space to add all of these things in the pipeline. But the fact is that I didn't train new embeddings to help me matching construct names and what I call mathematical concepts. But I could have had it that the model was not trained, so that's why I didn't put it in the final model.
Got it. Okay, thank you so much. That is helpful. And it's cool you were able to use some of your like domain knowledge here with high school math to help you in this competition. So
Yeah,
congratulations.
thank you very much.